Good morning, Michael, and welcome to the show. Today we will be presenting to you the Burning Candle Seesaw. Here is Garrett to explain more.
Okay, so for this experiment, you'll need a lighter, some scissors, a couple things to poke holes with, a plastic cup, a ruler, 2 straight straws, a paper clip, a couple candles, and a piece of paper to catch burning candle wax. So the first thing you want to do,
How are we going to build this, Garrett?
that's what I'm about to explain. So the first step of the building is you want to poke a hole in the bottom and the center of the plastic cup, big enough so you can put the straw in it.
You're really good at making that hole, Garrett. I see you put the large straw in first.
Yeah, it just has to be long enough because the top straw is going to rotate.
Okay.
Just like that. Next, you want to take your paper clip, if I can get it off, and take the smaller loop and fold it out, and then take the shorter side of the small loop and bend it up, like that. And that will be your pivot point for the seesaw. And you put the J into the straw, or of the paper clip into the top of the straw, like that. Straighten it out.
There's slight similarity to the Nazi swastika.
And so the next step is you get your second straw and a ruler and measure and find the middle point of the straw and poke a
It
hole.
looks like about 2 inches.
Yeah, that'll be the
Or
middle
just
point.
about an exactly 4-inch long straw. And this one looks about 6 inches or so.
Poke a hole through the middle of the straw, trying to keep it pretty level so it's not crooked. And this straw is gonna go right on this paper clip, and that's gonna be what rotates.
Oh, it's right on the L side. I see, it makes sense now.
And this straw is also going to be the one that our candles go in. So you want to put one candle in each side of the straw, about the same distance in, with a snug fit so they don't fall out. Just get them to where they're about equal in the straw. And you put this on the pivot and get the candles to where they'll balance out.
Alright, It's
Okay.
nice and even now. Equal weights.
So now what you want to do,
Good 2 lighters.
no, you don't light it. You want to light one candle slightly before the other, so they're burning at different rates.
Why is that important?
You'll see.
So easy.
I'll help you with that. Alright, so here, see, Garrett obviously doesn't know how this experiment works. So this is how the real masters do it. They light one side, wait a few seconds, I'll give it 3 more. 1, 2, 3. Then, you'll light the other side. See here, this one has already dropped some a little bit of wax. So it lost more weight than this one. This one just dropped some, it topsy-turvys a little bit. As it drops wax, it loses mass. Don't do it. Don't do it.
I get like a quick walkthrough so I can like be featured in the video?
Oh, guest star.
It's working. It's working. It's working. It's working.
Wow.
Oh,
This is what happens when the master lights it.
actually moved it.
You see how it's seesawing? This is rather an eccentric experiment in physics, very advanced. We should probably all get 100s in the class for this.
Oh god. It's like balls of fire.
This is a ball of fire. It is just dropping fire like nobody's business. This one, however, is not. Oh, but this one just dropped. So it's losing mass and switching tops of turbining. Look at that. It's almost upside down. It is dropping fire like a madman. Wow! When it switches sides, it starts melting on that part and moves up the wick. Look how big that flame is. Dude, I should go into showbiz.
Okay, so how this relates to kinetic and potential energy is when they're at equilibrium right here. You light one, but then so it's burning for longer, so the wax melts, and as it drops wax, it weighs. There's less mass on this side than there is on this side, so it loses potential energy and gains kinetic energy.
Dyslexic guys.
So it falls down, which makes it burn faster as the flame's more angled up the candle. So it drops more mass and loses less potential energy, and then gains kinetic energy as it rotates to the top.
Would you say that demonstrates angular momentum, kinetic and potential energy?
I did.
Wow. Wow.
There you have it. That's the burning candle seesaw.
Also, it exemplifies a fulcrum, because a fulcrum.
Okay.
Because a fulcrum is when a lever goes across a pivot point. The lever in this case is the straw with the candles on each side, and the pivot point is the paper clip. As it goes up and down, each side loses mass and goes up and down just as a seesaw would. However, with a seesaw, there's little children with legs pushing up and down. But with this, there's no legs. It's just lowering and gaining mass. Going up and down, and up and down. And that, folks, is the burning candle seesaw.